in 1519, when Spanish conquistadors marched over the mountains into the Valley of Mexico. They did not just find a city, they found an impossibility. Before them lay Tenochtitlan, a metropolis of over 200,000 people, larger and cleaner than London or Paris at the time. But what shocked the Europeans was not the gold or the pyramids. It was the fact that this massive empire was built on a saltwater lake, with almost no traditional agricultural land. Yet it produced so much food that starvation was virtually unknown. They had stumbled upon what is arguably the most intensive, resilient, and brilliant agricultural system ever devised by human beings. It was called the Chinampa system, often loosely translated as floating gardens. But to call them gardens is a massive understatement. They were biological engines. They were self-watering, self-fertilizing, continuous harvest food factories that defied every rule of European farming. European agriculture, then and now, relies on a linear concept of extraction. You find a piece of dry land, you chop down the forest, you plow the soil, exposing it to the sun and wind. You plant a single crop, like wheat. You rely on rainfall, crossing your fingers that it arrives on time. You strip the nutrients from the dirt, harvest your crop, and then you either abandon the field or haul in massive amounts of manure to artificially force the soil to recover. It is a system of constant struggle, constant inputs, and constant risk. The indigenous people of Mesoamerica flipped this logic entirely upside down. They did not search for dry land to plow. They looked at a swampy, brackish lake and saw a nutrient trap. They understood that water naturally collects organic matter. Gravity pulls every dead leaf, every piece of animal waste, and every gram of eroded topsoil down into the lake bed. The bottom of a lake is not dirt, it is liquid gold. It is centuries of highly condensed anaerobic compost. So, they did not drain the swamp. They brought the farm to the water. They staked out rectangular plots in the shallow lake using long poles made from the ahuehuete tree, a type of water-loving cypress. Then, they began to weave thick mats of reeds, branches, and aquatic vines between the poles, creating a porous underwater fence. Once the perimeter was built, they began the heavy lifting, using canoes. They dredged the thick, black, nutrient-dense muck from the bottom of the lake and piled it onto the reed mats. They layered this black mud with aquatic weeds, night soil, and food scraps. They kept piling, layer by layer, until the surface of this artificial island rose a few feet above the waterline. This was the Chinampa. And the genius of this design was invisible to the naked eye, because the island was built directly in the water, and because the soil was spongy and highly organic. It operated through a principle called capillary action. If you dip the corner of a paper towel into a glass of water, the water climbs up the paper against gravity, that is capillary action. The Chinampa did the exact same thing. The water from the lake was naturally wicked up into the root zones of the plants, 24 hours a day, 365 days a year. There was no need for irrigation. There was no waiting for rain. The crops had permanent, unhindered access to exactly the amount of moisture they needed. But the system was not just about water. It was about stacking biological functions, much like the ancient Chinese polyculture ponds. The canals between the Chinampas were not just waterways for canoes to transport goods, they were active fisheries. They teemed with small fish, frogs, waterfowl, and the axolotl, a unique aquatic salamander. These aquatic animals produced waste, which continually fertilized the canal water. Aquatic weeds grew rapidly in this nutrient-rich environment. And here is the brilliant closed loop. When it was time to prepare the Chinampa for a new crop, the farmers did not buy fertilizer. They simply paddled their canoes into the canal, harvested the thick aquatic weeds, scooped up a fresh layer of bottom muck, and spread it over the growing beds. The waste of the canal became the fertility of the farm. And what they grew on these beds was equally revolutionary. They did not plant vast fields of a single crop. They planted the Milpa. The Milpa, also known as the Three Sisters, is a polyculture triad consisting of corn, climbing beans, and squash. The Milpa is a masterpiece of companion planting. The corn grows tall and straight, providing a living, structural trellis. The beans vine up the corn stalks. But more importantly, beans are legumes. They harbor symbiotic bacteria on their roots that pull nitrogen directly from the atmosphere and fix it into the soil. They manufacture fertilizer out of thin air. Finally, the squash is planted around the base. Its massive, umbrella-like leaves spread out, shading the soil, preventing moisture evaporation, and suppressing any competing weeds. Together, the corn, beans, and squash produce a complete amino acid profile. They provide all the complex carbohydrates and proteins a human body needs to thrive. And because the Chinampas were constantly watered from below and constantly fertilized by canal dredging from above, the Aztec farmers could achieve up to 7 distinct harvests in a single calendar year. Let that sink in. Modern industrial agriculture struggles to get 1 or 2 harvests a year from degraded soil. The Chinampas produced 7. So why don't we see this everywhere today? Why is this system considered a lost relic? The destruction of the Chinampas was not due to a failure of the biology. It was the result of a cultural collision. When the Spanish conquered Tenochtitlan, they looked at this water-based civilization and did not understand it. Their paradigm was land, plows, cattle, and sheep. A city built on water was alien to them. And what is alien is often perceived as a threat. The Spanish wanted horses, they wanted sprawling pastures, they wanted wide roads for their carts. So they made a decision that would permanently alter the ecology of the region. They began to drain the lakes. They built massive drainage tunnels to empty the Valley of Mexico, transforming a lush, self-regulating water world into dry, dusty plains. As the water disappeared, the capillary action stopped. The canals dried up, the fish died, the nutrient loop was broken. The Chinampas collapsed, not because they were inefficient, but because the foundational element, the water, was stripped away by a government that valued conformity to European methods over the incredible localized efficiency of native biology. Today, what is left of the Chinampas can only be found in a small area called Xochimilco in southern Mexico City, mostly relegated to tourist boats and a handful of dedicated farmers fighting to keep the old ways alive. The dominant system of agriculture became the one that required tractors, synthetic fertilizers mined from the earth, and complex, fragile supply chains. But just like the polyculture ponds of ancient China, the biological truths of the Chinampa cannot be erased by history. Capillary action still works. Organic decomposition still creates rich soil. Companion planting still stacks yields. The rules of nature have not changed. Only our willingness to work with them has. The beautiful truth is that you do not need to live on a lake in Mexico to harness the power of this lost method. The core mechanics of the Chinampa, sub-irrigation, localized composting, and stacked polyculture can be engineered into a backyard of almost any size. Modern permaculture has a name for this adaptation. It is called a wicking bed. A wicking bed is essentially a Chinampa in a box, and building one gives you a level of drought-proof, low-maintenance food security that traditional raised beds can never match. To build a modern Chinampa system, you start by creating a waterproof container. This can be a deep wooden raised bed lined with thick pond liner, a repurposed cattle trough, or even an old IBC tote cut in half. The goal is to hold water at the bottom while keeping the soil dry at the top. At the very bottom of your container, you create a water reservoir. You lay down a network of perforated PVC pipes, including one vertical pipe that reaches up above the soil level. This vertical pipe is your fill tube. Then, you fill the bottom several inches of the bed with a porous material like gravel, expanded clay pebbles, or pumice. This layer will hold the standing water. Over the gravel, you lay a piece of geotextile fabric. This is crucial. The fabric acts like the woven reed mats of the ancient Aztecs. It prevents the soil from washing down into the water reservoir, but allows moisture to wick upward. Finally, you fill the top half of the bed with the richest, most organic compost and soil blend you can create. This is your artificial island. When you water this system, you do not spray the top of the soil with a hose. You pour water directly down the vertical pipe into the bottom reservoir. The water fills the gravel layer, and then biology takes over. Capillary action pulls the moisture up through the fabric and into the soil, keeping the root zone perfectly and consistently damp. The advantages are immediate and shocking. Because you are not watering from the top, The surface of the soil stays relatively dry. This drastically reduces weed seeds from germinating. It prevents fungal diseases that thrive on wet leaves. And most importantly, it reduces your water usage by up to 80% compared to traditional gardening, because almost no water is lost to evaporation. But to truly honor the Chinampa, you do not just stop at the watering system. You recreate the biological loop. You do not plant rows of lettuce. You plant the modern Milpa. You plant densely. You combine deep-rooted plants with shallow-rooted ones. You mix heavy feeders with nitrogen fixers. You can grow tomatoes up a central trellis, plant basil around the base to confuse pests, and let nasturtiums trail over the edge to provide a living mulch. You are creating a localized jungle, and instead of dredging a canal, you build a small worm compost tower directly in the center of the bed. A simple PVC pipe with holes drilled in it, sunk into the soil. You drop your kitchen scraps into this pipe. The worms eat the scraps, travel through the holes out into the soil, and distribute nutrient-dense worm castings directly to the roots of your plants. The waste becomes the fertility. The loop is closed. If we zoom out and look at the fragility of the modern world, the relevance of this ancient technology becomes glaringly obvious. Our current food system relies on diesel fuel to run tractors. It relies on global shipping to transport chemical fertilizers. It relies on massive, depleted aquifers to spray water over bare dirt, half of which evaporates before it ever touches a root. When the price of fuel spikes, food prices spike. When a drought hits, crops fail. We have built a civilization on the assumption that the supply chain will never break. But history tells us that supply chains always break eventually. Fan Le knew it in China. The Aztecs knew it in Mesoamerica. True security does not come from a grocery store. True security comes from establishing systems of permanent fertility that do not require external permission to function. When you build a wicking bed in your backyard, when you pair it with a small polyculture pond, when you start stacking these ancient biological engines, you are doing more than just gardening. You are actively seceding from a fragile system. You are taking your calorie production into your own hands. You stop fighting nature, and you start giving it a framework to do what it has wanted to do for millions of years: create abundance. It takes work to build the container, whether it is weaving reeds in a lake or lining a wooden box in a suburb. But once the container is built, the biology does the heavy lifting. Imagine walking out your back door in the middle of a blazing hot summer. The neighborhood lawns are dead. The traditional gardens are wilting under the sun. But your wicking beds are exploding with green. Your corn is towering, your beans are climbing, your squash is heavy. You haven't watered them in a week. Because the reservoir below is quietly doing the work, you pull a massive, ripe vegetable from the vine. You toss the discarded leaves to your ducks swimming in the polyculture pond nearby. The ducks fertilize the pond. The pond water can be used to top off the wicking bed. This is not a fantasy. This is how humanity fed itself for centuries before we were sold the lie that food comes from factories. The knowledge was not lost. It was simply buried under concrete and convenience. But concrete cracks, and convenience has a price that is becoming too high to pay. The blueprints for unlimited, resilient food production are still here, written in the soil, the water, and the roots. It is time to start building the islands again.